Hello, good afternoon, and welcome to today's session. Once again, my name is Ridwan Salahuddin. Today, we'll be discussing more on Matplotlib. So how to further format plots with Matplotlib, as well as I'll say a little bit of annotating our plots. We have them here, creating multiple plots, then using the object-oriented interface, then plotting data from a data frame, then interpreting plots. Okay, so we'll do a little bit of recap of last class. So in the previous class, we talked about anatomy of a plot, where we discussed what makes up a plot in what makes up a plot. So from the legend to the title, the labels, X and Y axis labels, the minor and major ticks, the grid line, the axis, and so many other things that make up a plot. Okay, so next we discussed how to create a figure container for plots. So how to create a figure container for plots. So we said any plot has to be in a figure. And in fact, you cannot have a plot without having a figure, because a figure is like the canvas on which you create the plot. Then we discussed about the types of plots, the various types of plots: bar charts, pie plots, histogram, scatter plots, box plots, and many more. Then we also talked about how to create simple plots using the PyPlots API. So using the PyPlots API, how to create simple plots. Then finally, we discussed the PyLab module. So we're going to do a little bit of review of some of these things hands-on now. So let's see how to create a figure container once again. So we said, as always, the first thing to do is to import the necessary modules. So here we import Matplotlib PyPlot module. So Matplotlib is a package and PyPlot is a module in it. So we import matplotlib.pyplot and we give it an alias. We say PLT. So there's an alternative way to doing this. I could choose to say from matplotlib import pyplot as PLT. I could also choose to just simply import without using an alias. I could simply do this without using an alias, such that anytime I want to make use of pyplot, I'll have to first call pyplot dot whatever function and method I want to use. But to avoid having to type this 6-character word, so we're using an alias PLT that's of course shorter to use. So I've explained why I would not be using this, because it's longer and you'd want to make it easier for you to use, so we won't be using this. So, but I want to show you that both this and this will do the same. So you can see this imported PLT successfully, and this also did the same. This ran as 105 and this as 106. So either way you choose to do it, it's going to work just fine. Okay, so here now, let's create a figure container. So we'll say, let's call it fig. So plt.figure. So this is tell Matplotlib to create a figure for us. So there's a default, there are default arguments that have been set here. If we look at the help, so here num is none, fig size is none, all these things that are none. So being none, being none as they are, automatically a default value is going to be set for them. So this num, for instance, is just going to create one figure container. Then the fig size. So fig size is going to create the default figure size. I think it's usually 4 by 4. Welcome back. Has everybody been hearing me?
Yes, sir.
Okay, thank you. I had a slight break in connection. Okay, so now, so this is simply going to create a figure for us with default values. So, and we can see it has created the figure as we have it here. But the figure has 0 axis, as you can see. So because it has 0 axis.
I can't see your screen.
Oh, I'm sorry about that. I'm going to share it. Okay, so I ran this cell and I said we can see it returns a figure object, but this figure object is with 0 axis. So it's with 0 axis. So this figure object has no axis in it. So that means we can't see, and we know it is the axis that actually creates the shape of the plot that we see. So in the absence of axis, we don't see any shape created, but internally, it has created a canvas, so to say. So, but the canvas has nothing written on it, and that's why you can't see anything written on the screen here. Okay, so in order to add axis to it, there is a method of fig that is add axis. So this adds an axis. So let's just add axis, and in order to add axis, you have to specify the parameters of the axis, so to say. So for instance, if we were to run this, it's not going to create anything because we've not specified the parameters. My connection went off again. I'm sorry for the incessant breaking connection. Okay, so we're going to add axis here and assign it to AX. So we'll run this. So now let's see whether we have an axis. It's empty because we didn't specify some parameters there. Let's see the parameters it takes. It takes a rectangular parameter. So because the axis has to be a rectangle, right? So we have to specify the parameters of the rectangle, like the bottom, the distance to the right, distance to the top, and all that. So we have to specify these these 4 parameters. So typically we'll do something like 0, 0, say we want 1, 1. So, and this is going to create, so we can see that we now have our axis added to it. So prior to doing this, we only had the figure created, but the figure didn't have any axis on it, so we couldn't see anything. So if you were to just print this, it will tell you that, okay, this is a Matplotlib axis. So with this, now you can create a plot. It appears my connection is not quite good today, and we're having regular break. So we'll see whether it stabilizes very soon. if it doesn't stabilize, we may be forced to reschedule the class. I guess it's the weather that's causing it. Okay, so we've seen the axis created on the figure object. So now we're now trying to add plots to the axis. So for instance, let's just plot 1 against 5, for instance, and let's see it. So, okay, sorry, we have to do this in the same cell. Yes. So, and
you can't see your screen. Oh,
I'm sorry. Okay, so I take it again. So I think everybody cut it up to the extent that we created this axis on the canvas, right? We all got it up to this extent where we created this.
Yes.
Okay, so now we're trying to add plots to it. This is just an empty axis plotted. So there are no values plotted on this axis. So we want to add plots to it. So let's say I want to plot 1 against 5, 1 on x-axis and 5 on y-axis. So just like your normal graph, you search for 1 on x-axis and 5 on y-axis. So forget that it is 1 point, it's entered at 1.0 here. It can extend beyond. So let's do this and say plt.show. Do you remember that we always have to tell PyPlot to show our plots? Although if you don't tell it to show it, Jupyter Notebook is able to show it nonetheless. However, if you are plotting on your Python interpreter rather than Jupyter Notebook interpreter, it's not going to get shown. So always remember to call plt.show. Okay, so I ran this and it doesn't quite show anything, which I'm a little bit surprised. Okay, so I'm going to add an annotation. Yeah. Okay, so I just added this annotation, this formatting. I told you, okay, make this a star and make the color blue. I think we saw this yesterday as well. I could have made it something like this, and it's all going to work as well. So we've seen how this works. So this was one of the things we learned yesterday. Then we also learned how to create simple plots. I think I've covered almost everything here, creating simple. So this is like a simple plot. We could add more values to it here by saying comma 7, 8. So I'll do the same here, 5, 10, 15, 20. And here we're going to have something like this. If I wanted it to be connected by dash, I'll just do like this by line. If I wanted it to be a line plot, I'll just use this instead. So this color will be changed. G will be for green, R will be for red, and so on and so forth. If you go into the documentation, you will see more about it. Okay, so before we proceed, we're going to have this short quiz. So I'm posting it to the message box for everybody to see. All right, so let's get that completed within 2 minutes. So by 5:17, we'll resume back to the class. Let's get that completed in 2 minutes. Yeah, so this is what the quiz looks like. Just 4 questions. Yeah, just 4 questions, and okay, 5 questions, but they're not quite difficult, very straightforward. Okay, so we should be done by now. So let's resume back to the class. So we don't have any response yet. It's taking quite a while. Okay, we can just go back to it later. We can go back to it later. It's just for knowledge sake. Okay. So today we'll be discussing using the object-oriented interface of PyPlot, then creating multiple plots, then more on plot formatting, then plotting data from a data frame, then interpreting plots. Okay. So using the object-oriented interface, let's start from there. So as usual, we start by importing our modules. Okay, so let's just do this little bit of exercise first. Sorry, not an exercise really, but let's start from here. So here, let's create, before we go to the object-oriented interface. So this approach here can be used to create multiple plots as well. Okay, I think this should be discussed after this part. Okay, let's just start with, creating multiple plots using the object-oriented interface. I beg your pardon. So in order to use the object-oriented interface, you have to create plots like this using the plt.subplots. So these are the parameters this method takes, and we will use just a few of them: number of rows, number of columns, and I think that's what we'll be making use of in this illustration. So we'll create an object and a subplot, an object that is going to have a figure and the axis at the same time. So this is going to create the figure and it's going to create the axis at the same time. So when you contrast it to the illustration we showed earlier, where we first created the figure, then we were adding subplots to it, axis to it. So here instead, we'll create the figure and the axis at the same time using the subplot method. So we're saying we want just one row and one column here. So it's effectively going to give us one axis. So, and we're going to create this plot on it. Before we add the plots, let's just run this and see what it gives us. So here we get both the figure and the axis created at the same time. And we can see our axis here. All right, so here we add plots to it and we say plt.show. All right, so and that's it. So now, using this approach, we can create multiple plots. So, but yesterday, I should have shown another way of creating multiple plots before coming to this approach. So, and that approach is using plt. Well, don't get it confused with this. In this, using this approach, we first specify from the start that we have this number of subplots. This number of subplots in our figure, and it's going to create the number of the specified number indexed by axis here. We'll understand as we go further. We'll understand, and if anybody doesn't understand, please just call my attention to it. But I'll ensure I explain it the best way possible. So, but before we go into that approach, as I was saying, let's see this other approach using plt.subplots. Now, what this approach does, the difference is this one doesn't have S, while this one has S. That's one difference. The second difference is this one creates both the figure and the axis together. You can immediately specify the number of axes you want to have in the subplot. So whereas in this example, you can be creating the subplot on the fly. All right, so what we have here is essentially our data. So you can ignore this. Don't try to think about it, at least not for this class. So here we're now saying, okay, we want to create a subplot. This subplot method, you can specify number of rows, number of columns, and the index. So take, for instance, this plot here has just one row and one column. So one row by one column just has one item in it. So it's just going to have index 1. So the index starts from 1 and not from 0. Yeah, we know Python is 0 indexed, but index in the case of plots, Matplotlib plots, starts from 1. All right, so this specifies the row. The first number specifies the row, the second specifies the column, and the third specifies the index. So here we're basically saying we want 2 rows and 1 column. So if we have 2 rows and 1 column, is effectively saying we have this and we have another one right below it. So that's like 2 rows, then 1 column. So the first item is index 1 and the second is index 2. So we're now saying this is index 1. Now, okay, create this, but we want to access index 1 first. So it accesses index 1 and it creates this plot on index 1. So this plot is basically created on index 1. So to see what happens, I'm going to comment this out and run this. So we effectively have this index 1. We can see that, yeah, if we look at this, this is one axis, this is the second axis. So on this first axis, we've created this plot. So, but because we didn't create the second plot, it just hides away the second axis. So if I uncomment this now, so we'll see that it's going to create, still telling it that, okay, it wants 2 axes, 2 rows and 1 column. Now, at the second index, create this plot. So it's going to create this plot on the second index. So let's run this now, and we see that we have 2 rows and 1 column. So this is the first index item, the second index item. So now, this approach can be a little bit ambiguous or difficult to comprehend. So we'll go to the main approach we are discussing today, which is using the subplot method. So here we're creating a figure and specifying its axis using the plot.plc.subplot. So here, number of rows is 2, number of columns is 2, and we're setting the fig size. What dimension do you want the figure size to be? And we're saying 16 by 16. So now, this fig is just one figure. All the axes will get plotted on it. However, axis is going to have 4 because we have 2 by 2. So 2 by 2 is 4. We're going to have 4 items there. So now we're going to have 4 items, as I said. Now we'll try to unpack, but before this, let me just uncomment the other parts, and I'm going to print out axis so we can see what it looks like. We'll print out axis. We'll print out shape. So let's run it. So we can see this is the axis object that is created. It has 4 items in it, and even by checking the shape, you can see it's a 2 by 2 matrix. And we can see it clearly here, 2 by 2 matrix. So we now need to access each of them because we need to create plots using each of these axes. This is the first, this is the second, this is the third, and this is the fourth axis. We can see the axes have been created on the figure. You can see them here. So now using each of these axes created here, these are the identifiers of the axis. So now I'm using these identifiers. We're going to create plots on them. So let me uncomment. Yeah. All right. So first, we need to access each of the axes. So we do that by unpacking the axis. So we know axis has this shape: axis 1, axis 2, axis 3, axis 4. Like, I mean, it looks something like this, right? So we have the outer list or array. Then in it we have a 2 by 2 inside it. So this 1, this 2, and each of it has 1, 2, 1, 2. If you remember NumPy, our discussion when we during the NumPy class, you should understand this. So now this effectively assigns axis 1 to this, axis 2 to this, axis 3 to this, and axis 4 to this. And using that, we're going to use each of it to create a plot. So axis 1, we're creating a plot, X, and this is our Y. Axis 2, we're creating a scatter plot, X, and this is our X, and this is our Y. So same thing with axis 3, we're creating bar, and axis 4, we're creating a pie chart. All right, so let's run it and see what we get. And this is it. So this is the line plot with axis 1, axis 2, which is a scatter plot, axis 3, which is a bar plot, and axis 4, which is a line plot, a pie plot. Okay, so that's basically how to create multiple plots using the PyPlot object-oriented interface or object-oriented method. So using the plots.subplots, we'll create it. So is there any question till this point? Or are there any questions? Do we have some questions? Does anybody have any question? Okay, so remember that you can always indicate you have questions by raising your hand through the chat. So if you raise your hand, then I signal that you can ask the question then, so that we don't go too far before you ask your question. Okay, so now we've seen how to create subplots and creating different charts using the axis of the subplots. So next we'll see more on formatting our plots. So for instance, we've seen yesterday how to add title, how to add labels, X and Y axis labels, how to add legend. So we'll see here how to move our legend around, how to add text to the plot, and so many other things that are possible. So you just know that you need to know that the possibilities that we have with Matplotlib is limitless. In fact, I doubt if there's any one person that understands everything Matplotlib can do. So you can almost know everything, but you might still have some things that will elude you. And those that are likely to understand almost everything it can do are the developers of it, the people that are responsible for creating and maintaining this package. So they are likely to have very broad understanding of it. So, but if you also look at them, they will be highly focused on Matplotlib, and they won't try to understand almost every module or package that exists in Python. Okay, so here now, in this example, so we'll create a figure, then we'll add axis to it. I've shown you before how you can create a figure, then add axis to the figure. Then using the axis you've added, you'll create plots. So here now we are saying we want our plots to be of color blue and to make use of round dots. So now we're also creating more than one plot in this. Yes, the plots module allows you to create multiple plots on the same axis. Multiple plots on the same axis. So we're creating these plots and setting this format, and we're creating these other plots and setting this format. So then we're adding text to it. So what we have here is specifying where on the axis grid are we putting this text. So if you need to understand this module, this method more, so you can either open up the help by holding down Shift and Tab, or you can simply go to Google and type pyplots.txt, for instance. So if I type that, you're going to see the .text API. So, and it's going to tell you all the things it can take. You can see text X, Y, which effectively locates where you want to place the text. Then this is the string you want to be displayed on the chart. Then these are other parameters, font dict, for instance. This is a dictionary telling it that I want the size to be 12. I want the color to be this. I want so there are, if you look at it here, a dictionary to override the default text properties. If font dict is none, the defaults are determined by your RC parameters. So that's basically, so you can set the font size 12, for instance. You can align it. You can set the alignment, horizontal alignment, vertical alignment. So you can do a lot of things. So it's actually very important that you get used to opening up the documentation and reading into it, trying to understand what other things can be done using those. Okay, so we'll do this. Then we're going to set the title. Then we're also going to set let's set the X label. So X label, let's call it X axis. So let's run this. Then also we yesterday I said we're going to show how you can add grid. So, and I told you that there is a method called grid.grid. So plt.grid. So this LW equals to 1.25 is only telling Matplotlib that I want the width, line width, the width of the line to be 1.5 pixels. It can be less, it can be more. So let's run it and see what we get. So we get, effectively, we get two plots. One is of the blue lines and the other is of the red lines. Then we have this text illustration printed here. We have the font size 12 and it can be changed. For instance, I can make it 22. I can change the color to orange. And let's see. Oh, sorry. Say, for instance, I can change it to red. Yeah. So we can see the size is bigger. And I can also change this thickness, the line width, to be something bigger. I can see it's thicker now. And so many other. We can also add a color to it. Say color P. Oh, sorry, there's nothing like that. Okay, so I don't know all the colors it accepts. I've never bothered to check, but I use mainly the blue, green, and yellow and all that. So I'm changing it to blue for Okay, welcome back, everybody. Okay, so we've seen some formatting that we can add to our plot. So even the title here, we can also add color to it. So let's say we want it to be green. Excuse me. So I just changed the title to green color. So we can do a lot of awesome things as required.
The screen is black.
The screen is black.
Yes.
Okay. I'll try to see why. How about now?
Yes, I can see it now.
Good. Okay, so we've seen how we can add these various formatting, and you would have to actually explore much more to uncover a lot of other things that can be done. If you check the end of this notebook, I added a link to the Matplotlib documentation, as well as another website where you can learn more about this Matplotlib library. So, for instance, in this grid as well, we can also specify that we want it to add. We want it to add both the major and minor grid. So under the which, which. So we can say we want both, and if I run it, excuse me, it's not showing the minor grid. Okay, so typically it should show both the major and minor grids because I indicated both. Let me try to see why it's not showing a minor grid here. Set title. Oh, I'm still trying to see why. Ideally, it should show the minor grid. Let me specify just the minor here. Okay, so it's not even showing it at all. Okay, let's just move on. I can't figure out why it's not showing the minor grid, but I'm guessing it's okay. Let's move on. We've seen how to add various formatting to it. So we've seen how to add this text. We can change the position. If I were to alter this to say 30, it's going to bring it down. So we can see the text has been brought down here. If I make it 80, for instance, takes it up, we'll see it here. So can change the color, can change the font size as well. Yeah, many other things that can be done to it. Okay. So is there any question at this point, or is there anything you are thinking, okay, is it possible to do this? Any question? Okay, so let's move on. Now, plotting data from a data frame. So you, in reality, what we've been doing so far, we're just creating our data on the fly and plotting it. So we've been creating the data and just plotting based on about. In reality, you will have data probably in tabular form or in an array form that will be supplied to you, and you will have to post the data in a form that you can create plots from. Okay, so here let's assume we are giving data in a tabular format. So we're reading the data from this URL. It's the data we're familiar with, air quality data. So in order to, I've run the cell, it's currently loading the data. So in order to create, okay, so when we discussed, last week when we discussed pandas, we saw how we could create plots with pandas, right? So there are a lot of plots, and I will advise you that except you want a very, very high level of control that cannot be achieved with pandas, that's when I'll advise that you use Matplotlib. Else, if anything you want to do can be achieved with pandas, any plot you want to create, so I'll advise that you make use of pandas, because pandas is much friendlier than Matplotlib, in that you don't need to, for instance, create a figure object first, then create plots, then show and all that. So you can simply call df.plot, and you're going to get whatever kind of plot you specify. So, however, if you must use Matplotlib to create your plot, so you will need to specify the columns you want to plot and specify those as either NumPy arrays or series objects, because Matplotlib works best with NumPy arrays or series objects. We've discussed in the past that series objects are quite close to NumPy arrays. So Panda series are quite close to NumPy arrays. So what we're doing here is basically creating series objects from the data frame. So first is we're accessing the data frame df and say, okay, return the column date time. So take note that if any of these column names were to have space in between, it wouldn't be possible to access it using the dots, using this attribute method, this attribute approach. So you would probably have to do something like this in order to access it, which does the same thing. But in a case where there is a space, for instance, if these were date space time, this is the only way you can access it. You can't use the other notation, the notation we use in these other examples. So I'll leave this like this. So now dot value. So this dot values extracts the series object, ensures that you only get in the series object here. I'll do the same thing here. I'll do the same thing here, and the same thing here. So when I run this, I didn't remove the space here. Okay, so I've assigned all these columns, the values in these columns, I've assigned them to new variables. So for instance, let's access the date time variable. So we can see it that it returns an array. So by calling values on it, we have converted it to an array object. So if we do the same thing for Paris, we get an array. We do it for London. We do it for London. We also get an array. So Excuse me, please. Okay, sorry for the slight break. All right, so now using this array, we're going to create our plot now. So first thing to do is we'll create our figure object and the axis. So we want a 3x2 figure object that has 3x2. Let me just say 6. That has 6 axes. So 3 rows of axes and 2 columns of axes. And the figure size should be 10 by 10. Let me make it something bigger. Let me make it 16 by 16. So let's run this first and see what we get. So we get 1, 2, 3. And we have 2 columns, column 1 and column 2. So now we'll proceed to create plots on this axis. For instance, let's print axis and see what we have in it. We can see we have 6 objects in it. Let's check the shape once again, 3x2. So we need to access each of these objects one at a time and create plots with it. So what we'll do, instead of creating plots on all, so we'll create plots on this, which is the first item, and this, and this. So in order to do that, so we do something like this. X1 equal to, so we have axis. So now what we want is this. So remember, our axis object is a 3x2 array. So we want to access the first item, that's the column 1 and row 1. So column 1 by row 1. So we want column 1 and we want row 1. So this will give us that. So let's say our ax, we want to create one here, another here. This is row 2, column 2. So row 2, column 2. Row 2, column 2. So, and lastly, okay, so this is ax 2. So then ax 3. So row, now this one we want it to be on row 3, column 1. So row 3, column 1. Now we have our 3 axes that we want to create plot on. That means we're leaving the others empty. So if you run all axes out of bound, oh sorry, we're starting from 0. It's 0 indexed. I'm sorry about that. 1, 2, 0. Yeah, so that's it. So now using these 3 axes, we're going to create plots. So, but I'm going to copy these and paste it back here because it's meant to be run together. Remember, the figure object has been created here. So if I were to run it there, you should have lost this figure object and it can't create the plot of the axis. All right, so we have created the 3 axis object. So next is to create plots. I mean, we have accessed the axis we want to create plot on. So now let's create plot. So let's look at it. Let's assume we want to create a box plot of the London data. So let's start at 1 dot box plots. And we're using what? We're using the Pari data. So let's run this for instance. Excuse me, there's I'm trying to see what the problem is here. Axis 3 by 2. Oh. X1. Okay. So instead of doing this, let me use a simpler approach. Yes. So the way I accessed the NumPy object is what is creating the issue. So let's access it this way. Okay, so there seems to be an error. Invalid value encountered in less. Okay, so because we have some non-values, so I'm going to replace the non-values with. So if you check, there are some non-values in it, and it will know how to handle the. Excuse me. Okay. So I'll do that here first. Fill now. Fill now with 0. All right, so it works. So because we had some non-values, so that was why we had issue. It had issue creating the plot. So now I replace all the non-values with 0, and now it has created a plot. So this is a box plot. Now with the other axis, that's axis 1, axis 2 now. Should I call it axis 2 or even, because it's actually axis 4. 0, 1, 2, 1, 2, 3, 4, axis 4. So I think I should use axis 4, and the last one, axis 5. Okay, so axis 4 dots. So let's create a line plot. No, let's create histogram. So let's create a histogram plot with London data. So let's see it. So we can see our histogram here with the London data. It has skipped the 2 other axes. So finally, we'll create the last plot here in this subplot. So that's axis 5 dots. Now, what plot should we create? So let's create scatter plots. Now, these scatter plots, let's create it with both the London data and the Pari data. Box plots does not require you to create to pass in the values of X and Y. So it only requires you to pass in just a single array of values, and it's going to create the box plot. So when we get to the next part, we'll understand how the box plot works. So let's create a scatter plot of Paris against London. So there we go. So let's see it. So that's it. Paris against London. So you can see that you can basically access any of it. And so for instance, if I want to annotate each of it as well. So if I want to annotate Act 1 and I want to set the title, so I'll say set title and say box plots of Paris data. So that's the title. So if I want to do the same thing for London, so I'll say Act 4 dot, so assuming I want to add text to this. So I want to add text and I want the text to be situated at 250. Yeah, 250. So X is 50, location 50, Y is 200. And I want the text to be, say, histogram plot. And I want the color to be, red. Yeah, just that. So here, let's say I want to add grid. Act 5, I want it to have grid. Act 5 does grid. So I want the grid to be added. So I can just say add grid and that's it. So let's see. So we can see all that we added have appeared on our figure. So we have the box plot with the title. We have the histogram with a text in it and the precise location we set. And we have the scatter plot with grid in it. So is there any question at this point before we get to the final part of today's class? Okay, there is none. So the final part is just interpreting plots. So I won't be creating new plots. I'm just going to use these illustrations here. So let's try to understand what box plot is and what histogram is and what scatter plot is. So starting with box plot. So one of the very main reason, or let me say one of the main uses of box plot is to get a very quick understanding of your data. So quick understanding, what I mean by that is, and in a visual way. So you get an idea of where your mean is, for instance, where the median is, where the mode is, for instance, as well. The most frequently, sorry, you don't get mode, but you get the mean, the minimum value. You get the first quartile, the second quartile, and you get the maximum value. Then if there are outliers in your data as well, you will easily see where the outliers are. So now let's try to understand these box plots here. So in this box plot, these edges here are called whiskers. This and this are called whisker. Now, anything beyond the whisker, anything beyond this whisker is an outlier. So whether below it or above it. So it's called a whisker. Now anything beyond the whisker is called an outlier. I'm sorry, I beg your pardon. So anything beyond the whisker is called an outlier. So we can see here that we don't have outliers lower than the minimum value. But above the minimum value, we have a lot of outliers. And as you can see with these small circles here, you can see a lot of it. So, and we can see the most extreme one that's quite close to 100. So here now, this yellow line that divides this box is the mean. We can see it's just between 20 and 30, around 25, I think, around 25 or 26. So that's the mean of the Paris data. the minimum value is actually very close to 0. It's actually on 0 mark. So the minimum value is 0. The maximum value, not necessarily the maximum, but the excluding the outlier, yeah, excluding the outlier, the maximum value is here. So here we have our first quartile. Here we have our first quartile. Here we have the second quartile. And here we have the maximum value as well. So that's basically what a box plot does. So very easily or visually, we can explain our data with a box plot. Any question about box plots? So you can indicate by raising your hand on the chat. Okay, so histogram plots. So histogram plots gives you an idea of the most frequent values you have and the least frequent values you have in your data. So looking at this, we know our data ranges from 0 to somewhere around 100. We see that most of our data are actually less than 40 value. The values are actually less than 40, most of them. As you can see here, that bulk of it lies between 0 and 40, just few beyond. And beyond 60, beyond 65, 70 here, there are actually very, very few values there. So the most value we have is between 20 and 30. That's the most. So most of our values lie between 20 and 30 actually. So the most frequently recurring, the range of values that occur most frequently are between 20 and 30. So a histogram plot just shows you the distribution of values you have in your data. So looking at this now, I can say, okay, on most days or on most of the measurements range between 20 and 30. Okay, then next to it, we have between 30 and 40. So if I actually take between 20 and 40, I can say I have almost 50% of my data in that range. Almost 50, I think, yeah, about 50% of my data between 20 and 40%. And if I look between 0 and 40%, I'll say I have about 95% of my data there. So this is clearly not a normal distribution. I mean, this is a right-skewed, left-skewed distribution, I beg your pardon. So because if I were to smoothen it out as a curve, it's going to actually look like a left-skewed distribution. All right, so that's what a histogram plot is. So let's actually try to smoothen it out. I think, excuse me. So I'm trying to find the there's an argument that allows us to smoothen this plot. I'm trying to find the I can't seem to find it and I can't remember it. Okay, so that should be an assignment for you. If you want this to be a smooth curve, let me show you what histogram. Okay, let's actually find it. So we want to smoothen histogram distribute. with, I didn't add Matplotlib. So we can get our answer in one of the okay, yes. So, okay, so it's density true. Excuse me. Okay, it doesn't quite work. So I'll probably have to find that out and let us know. So let's quickly discuss scatter plot. So scatter plots, as you notice, we plotted this scatter plot using two different set of values. So we pass in our x values and the y values. So scatter plots allows us to visualize a relationship between two different values. So in this case, we want to see if there's a relationship between the Paris data and the London data. So for instance, we want to know whether when Paris data is high, is London data high? Or when Paris data is low, is London data low? Or when London data is high, is Paris data low? So we want to see whether there is a positive correlation or negative correlation or no correlation. So how do you know when there is correlation? Okay, so for instance, let's look at this now. We can't see any trend here. This is just like a blob of points plotted. So there's actually nothing insightful here. But let's think of something like this. This data spanning from this lower origin here, then stretching along this diagonal. Most of its concentration along this diagonal. So we would easily be able to conclude that these data, the two set of data are related. Or if instead it spans from the top left corner and extends down towards the bottom right corner, then we can easily conclude. As well. Then we can easily conclude as well that there is a negative correlation, because as the values on this x-axis is increasing, those on the y-axis are reducing. I'm going to show. So I want us to see what I'm explaining. Yeah. So what we have in this image, for instance, we can see this a classical example of negative correlation, stretching from the top left to bottom right. So, and in this image, we can see positive correlation, stretching from the bottom left to the top right. So, and this is another positive correlation, and this is a classical example of no relationship between the two sets of data, because there is actually no pattern here. So that's explains, or that's basically what I have to explain about understanding or interpreting plots. And this brings us to the end of today's discussion. Do you have any questions? Do we have any questions?
Yes, thank you very much.
All right, you're welcome.
Yes, yeah, on the scattered plot.
Okay.
Yes, it seems I can't get the difference between the two data.
Between the two data?
Yes.
Okay.
I didn't quite get it.
Okay. Okay. So Scatter plots.
What I'm trying to say is those plots or those dots, can they be differentiated with different colors?
Yeah, the dots can be differentiated with different colors. Yes, it's possible. But
okay, so it's not making it too clear with using the same color, or I'm not getting something.
Okay. Yeah, okay, I get that. Now, to answer your question, can they be differentiated with different colors? Yes, they can be differentiated with different colors. However, is it necessary? Is it going to add any extra information, especially in this illustration? No. And the reason is this. So let's go back to the data. So we have station Paris, station London. So what scatterplot is effectively doing is this. It picks this value here, none, assuming it's a value, and picks 23, and it plots. If station Paris is on the x-axis, it plots the value of that against 23 on the y-axis, and puts a dot there. So for the second value here, it does the same. So if there are 1 million values, it's going to do the same thing. So imagine using different colors for different points. You're going to have 1 million different points. So, and that's the reason I said it's not going to add any extra information. So there is actually a method, but you have to create the, okay, just a moment. There is a parameter C, I think. Yes, C. Let me be sure. Yeah, color. Yeah, C is for the color sequence. So we can pass in range. So let me say range. What's the length of 1035? 1035. Okay, so we can do something like this, right? But this does not add any extra information. I don't know if you agree with me, or you still don't understand why I said it doesn't add any extra information.
Yes, maybe I've not gotten the concept of the scatter plot actually.
Okay, so let me add labels to it. I think we have about 3 minutes more. If we have to, we'll have to rejoin the class so that we can round it up. So I'm going to quickly add label sets x label Paris at 5.set y label London. Okay, so now this is London, this is Paris. Now, this value here, for instance, is about 100, let's say 98. So the corresponding item on that row in this table, the corresponding item is for Paris, for the Paris column, right, is about 20, maybe 23, let's say 23. And that is how each of these plots is created. It's effectively just plotting points, corresponding points. So these are, okay, yeah. So it's plus 23 against this, 19 against this, 19 against this, 9 against this, 9 against this, and 9 against this. That is how the plot is created. So now what we want to see is, for instance, when this is high, when this is a big number, is this also a big number? When this is a big number, but smaller than this, is this also a big number, but smaller than this? When this is a small number, is this also a small number compared to each other, right? So that is the relationship that needs to be established when creating a scatter plot. And when you have such, you can easily conclude that, oh, so if I have an idea of what the temperature, assuming, okay, this is air quality. So if I have an idea of what the air quality in Paris is, can it translate, or can it give me some information about the air quality in London? Do you get this point I just made?
Yeah, yes, it's clear now.
So if I have an idea of air quality in Paris, does it give me an idea of air quality in London? That is what a scatter plot tries to create. So The idea can be positive or negative. For instance, now let's assume okay, so as we were explaining, so let's assume that the two variables have inverse relationship. For instance, maybe the temperature, you know, I think there's something called temperature inversion. So let's assume maybe in Lagos, for instance, when the temperature in Lagos is high, temperature in Abuja is typically low. So if we take recordings of temperatures in Abuja and Lagos for, say, maybe a period of 1 month, and we take it at time interval of 1 hour. So we measure at 2 o'clock, measure the temperature at Abuja and Lagos, log it. At 3 o'clock, we do the same, 4 o'clock. So we now notice that when we created this scatter plot, we now notice that the data spans from this top left to the bottom right, from this top left to the bottom right. So that means when the temperature is high in Lagos, it is low in Abuja. As it is dropping in Lagos, it is increasing in Abuja. As it is dropping in Lagos, it is increasing in Abuja. So we can easily see that there's a negative relationship between the two regions. So if I now come at a time and tell you that the temperature in Lagos is 40 degrees, you can easily guess that, okay, the temperature in Abuja is going to be very low. And you can guess that it's 20 degrees. So understanding this is very essential to what we'll even be learning next week. Because what machine learning tries to create effectively is something like a scatter plot, especially when we talk about the most basic machine learning algorithms, such as clustering algorithms, which is in the case of unsupervised learning, or things like KNN. We'll also discuss all those next week, at least an introduction to all of them, to be handled by a partner. So this does not show a relationship, this plot here, but the illustration I'm giving, if you're able to follow through, you'll see that if I know the temperature in Abuja, I can easily guess what the temperature in Lagos is. If I know the temperature in Lagos, I can easily guess what the temperature in Abuja is. And we can see that there's a relationship there. So do you have a better understanding of what a scatter plot is now?
Yeah, yes, very well. Thank you very much.
All right, you're welcome. All right, so we'll be creating very many of it. The essence of data visualization is for you to even see and establish this relationship. In most in most cases, when you're exploring data for analysis, or when you're trying to create a predictive model, you need to do data exploration, and what you are aiming to achieve is this type of relationship. You're trying to see whether there is any form of relationship between maybe two columns or two or more columns. And it will inform your decision as well as to what approach to use in order to create your model and all other things that you can think of. All right, so is there any other question? Okay, so we've spent more time than we planned to today, and at this juncture, we can bring the class to a close. Thank you for having me, and thank you for joining. Do have a pleasant evening. So the assignments, I think one assignment is due tomorrow, another is due day after. By tonight or tomorrow, I should send out the assignment for this week, and it's going to be due 1 week from now. So these assignments are essential to ensure you get some practice and get comfortable with doing all of these things. So please endeavor to get them done. Thank you.
Thank you, sir.
Thank you.